All right, let's work on identifying congruent figures in our next example. So given we have triangle ABC, here it is, triangle EFG is over here, and triangle JKL, which triangles are congruent? So to find congruent triangles, if we can come up with a composition of rigid motions that maps one triangle to another one, then those triangles would be congruent to each other. So that's what we're trying to figure out. One thing I want to point out is just a visual check to see which ones are we predicting would be congruent, and then we can show they are congruent with the rigid motions. So for example, here's what I'm looking at. Triangle ABC. To get from B to C, do you see how we would go up one and over 1, 2, 3? So I'm looking for that pattern of one, a movement of one, and then a movement of 3 to get from one side to the other. If I look at triangle JKL, and it's this KL side that's catching my eye, I can see if I move once and then over 3, KL is likely going to be the same length as BC. So I'm thinking maybe this is a triangle we can focus on. Is there a rigid motion that gets us from a composition of rigid motions that gets us from triangle ABC to triangle JKL? Do we have that up 1 over 3 from one vertex to the next over here? Well, from F to E, it's just straight. It's straight down 4. So that side wouldn't match. Does FG match? This one was up 2 over 3, and I'm looking for an up 1 over 3. So that one wouldn't match. And from E to G, this is over 3 and up 1, 2, 3, 4, 5, 6. So I am going to try to figure out how to get triangle ABC to map onto triangle JKL. So just a quick, observation makes me kind of cancel that out as an option. So let's see how we can get triangle ABC to map to triangle JKL. Okay, so we've got this nice visual again to see how this composition of rigid motions would work. Here's our triangle ABC. So our first step, let's translate ABC 3 units down. So there we can see each vertex went down 3 units, and this light gray, that's where our triangle is hanging out. Now, can we do anything to get it to map onto triangle JKL? So that's what we're looking for in step 2. So step 2, we can reflect across the line M, which is x equals -4. So if I click on that, here's our reflection line M. So you can see each point got reflected across from here to over here, from here to here. And if we compare this to the figure above, these are the vertices of JKL. So then last, we're showing that the composition of rigid motions, first the translation, we went 3 units down, followed by a reflection across line M, which is the line x equals -4, maps triangle ABC to triangle JKL. Because we had a composition of rigid motions that mapped one triangle to another, therefore we know that these two triangles are congruent.